File handling. In this nugget, we're going to take a look at a topic that's very popular among those who use Python for server and workstation automation purposes. Specifically, in this nugget, we're going to start by looking at how do we access the enclosing file system. Thus far, we've been working strictly within the Python interpreter. In this nugget and the next one, actually, we're going to broaden our horizons and actually touch the surrounding operating system, and in the next nugget, internet-based resources as well. I'm going to show you how to open up files for reading, how to create new files, how to write or append data to those files, and then close them when we're finished. There's a lot of really useful information in this nugget, so pop on your thinking caps and let's get to work. The file system. There are 3 Python modules that come baked into any current version of the interpreter that you need to be familiar with if you have any interest in going outside of the interpreter and hitting the file system on a local and perhaps remote machine. The first of those Python built-in modules is the OS module. I think we looked at this just a little bit earlier in the course when I showed you how to access Python documentation. Of course, OS stands for operating system, and in the OS module we have several built-in functions that we can invoke to do things like to obtain the current working directory, or CWD. This is going to tell us where our currently logged on user is in their shell environment, whether that be in Windows, Linux, or Mac OS X. We can use chdir to, you guessed it, change directories to move from one directory location to another in a file system. Listdir does exactly what you think it does. If you're a Unix, Linux, Mac OS X terminal person, you're familiar with the ls command. In MS-DOS and now Windows, we have the dir command. It's the same deal. There's some other OS module functions that we'll take a look at in the upcoming demo that are really useful for traversing a file system. You can also build directory paths using the path.join function. This is particularly helpful if your Python program is going to be ported to more than one operating system platform. Of course, you and I both know, if we're familiar with Microsoft Windows, that paths to local resources begin with a drive letter, say the C or D drive, and then using / characters we can walk through a multi-level directory path, ultimately terminating with some specific file resource. In Mac OS and Linux, it's kind of backwards in terms of the / becomes a /, and instead of a drive letter denoting the root of the file system for a particular partition or drive, in Linux and Mac OS X, simply the empty / denotes the base or root of that volume. As I'll show you shortly, path join is cool because we can parameterize paths to accommodate for these differences. Also, we'll see, and this is what I use in my own development, I will use the / always for all directory paths, even for Windows. This is a feature that Python shares with another open source tool with which I'm very familiar, the MySQL Relational Database Management System. As we've seen in the past when we covered escape characters in this course, if we're going to do a path in Windows, say c:\docs, you may run into problems. In fact, you definitely will run into problems using this as a string because the single / is interpreted as a escape character, and whatever letter follows that escape character is going to be performed. Whatever action that might be mapped to will be performed by Python. Otherwise, you're going to get a traceback. So if you insist on using the / notation, remember we're going to have to escape each one of those. Functionally, that means doing double / where a single / exists for universal naming convention network paths that normally look like / server name. Here, we're going to have 4 / server name. Cool. Enough with that. I also want you to understand that the OS module has a name function that will echo back an operating system specific identifier. This can be useful, again, if we're porting our Python program to multiple operating systems. We can create conditional branching paths based on the value of os.name on the system that the program's running on, and we can take one path.join operation if OS name comes back Windows, another one if it's Linux, another one if it's Mac potentially. OS name gives you fairly generic operating system platform details. The second module that you really need to be very familiar with to do Python file system work is the sys module. The platform function in there, sys.platform, gives a much more detailed ID of the host operating system of the local computer. The third module is the shell util, or shutil module. This is what I call the batch module. You can do batch operations. You can perform batch or bulk copies, batch or bulk renames, batch or bulk deletions, etc. Anytime you want to operate on doesn't have to be a humongous list of files or folders, it could be a small one, but where you don't want to perform a certain action one by one, you can invoke or import the shutil module and then just in a single function call accomplish your goal. In this first demo, we'll work directly within the Python interpreter and touch the host operating system. Now you can see right off the bat in idle that we're running Python 3.1.1, and the metadata here tells us that we are on a 32-bit Intel processor machine with Win32 as the host OS. That's good and good, but when you're running and distributing a Python program, we don't want to take anything for granted. Now, in order to get to some of those OS-specific functions, we're going to have to run an import. So I'm going to import the OS module, and then just for grins, we'll run the dir command on that module that gives us a list of all of the names found in that file. And if you scroll down and just spend some time looking, we're going to become very familiar with some of these, especially open, rmdir. Actually, a lot of these should have pretty familiar, intuitive names. These functions, I think, are well named. Of course, Python shows its Unix-Linux root in as much as a lot of the function names work identically or with little modification when you're in the Linux, Unix, Mac OS terminal environment. Why don't we play around with that path.join function I told you about. In fact, there's path right here. Let me highlight it. There we go. And what I'm going to show you how to do is build an already existing path. Now on my system, I have a folder called Files, and you see I have a bunch of sample content in here that we're going to be poking around into in just a little bit. Some text files, a JPEG image, a Microsoft Word document file, a PDF file, and a subfolder that has a whole bunch of text files in it. Now in our code, we can definitely change directory. I'll show you how to do that in Python interactively in just a moment. But if we wanted to build a persistent path and say attach it to a name, we can use the assignment operator to set, in this case, I'll open up os.path.join, and you notice that two arguments are required here. I'm going to join the root of drive C and the files directory. Now this isn't going to make a directory. We have to have the directory already in existence in the file system. If we want to see the contents of P, first let's run a type on P. Tells us that it's a string. If we echo back P, it gives us the combined path name, C:// if that makes sense, files. If we want to run an ls or a dir, we can call os.listdir and then pass in the name of that name, which is P. The feedback from listdir is, of course, a list, and you see now one-to-one the contents of C:/files. Easy as that. Next, let's play with os.name. That just comes back with a fairly generic identification of the host OS. If I were on a NIC system, it would come back as POSIX. Actually, POSIX is what comes back even for Mac OS X systems. If you want richer information, we'll want to import the sys module, and we can run sys.platform. This tells us we're now on Win32. If you're on Mac OS X, it'll come back Darwin. Darwin's the name of the OS core on that platform. Or you'll see Linux 2 on, say, an Ubuntu or other current gen Linux machine. Just for grins, let me show you this. Now to pseudocode or parse out what I've just typed, you see on the outermost level I'm running the print function, which tells Python we want to see a pretty print or a nicely formatted print output. Inside that print, you see we have a call to the list function, which we've already become well familiar with. You'll remember that you can throw, say, a string or other object at a list function, and list will come back with, you guessed it, a list of values. What are we passing into the list function? We're using the namespace os.environ, Environ is exactly what you think it is. It's how we can access the environment variables on the current system. Items should tell you that this is a dictionary. Remember, keys and items and values, and we're getting back everything here. So if I hit enter, I see a list come back that gives us all of our values. Now, they don't look particularly good. They're just simply key value pairs. The value of my TMP environment variable is this path. The computer name value is this guy right here. My Windows NT domain is this here, and so on. There's other options we could do to make this list output look even better yet, but I'm just wanting to give you a flavor of how this works. One nice example way to present our environment variables in a prettier way is just to use an iterator, right? To use a for loop here where we're iterating through os.environ.keys. A key is the first part of these two pairs we see in each list element, and we'll just come back printing the value of the parameter, comma, and then its value itself. You see? A little bit easier to look at, wouldn't you agree? Let's work with accessing directories in the parent file system. I'm first going to run a call to os.getcwd, no parameters necessary here, to give us our current working directory, which, no surprise, is c:\python31. As I've already shown you, we can do a directory listing of that location or any location by calling listdir and then passing in a specific path using single or double quotes, or if we had a name defined, like earlier where we used the join function, we could do that. Or actually, check this out. We can call os.curdir, which of course stands for the current directory. So there's the contents of c:\python31 as a simple Python list. I think it's great, frankly, that most of what we see here with these OS shell commands gives us lists back, because as you know, lists being mutable object types, we can pretty much do anything we want under the sun to those list objects. If we wanted to switch over to our files directory on the root of drive C, that's easy enough. We can call os.chdir, and in this case, I'm going to pass in a string literal, c:/files. And now, of course, if I get the current working directory, we're in the files folder, and of course, if we run our listdir, we should see a different list of files, and we do. If I want to rename a file, you notice we have one called junk.txt. We can simply do an os.rename, and you see the balloon help says old comma new. So we'll say junk.txt, comma, not junk.txt. And you'll notice that I received a couple tracebacks here where the specific error that Python raised was Windows error. This process cannot access the file because it is being used by another process. And actually, I do have that file open. So what I did is simply recast the rename function and threw in what's new.txt instead, and I've renamed it to please read. Now these tracebacks are actually a good instructional moment for us. When we manipulate files, when we do things like renames and opens and reads and writes, we are opening a file handle that hits the operating system. So as far as the host OS is concerned, Python process does have control of that file. So for instance, you're not going to be able to open and write a file that's already been opened by Python in, say, another program. You see what I mean? Now if I call listdir, we should and definitely do see that the file was successfully renamed to pleaseread.txt. Let me show you how to make a directory. It's just os.mkdir. I'll call it more files. I'll do it again. Call this folder delete me. The reason why I'm doing that, of course, after I run another listdir, is to show you how to remove a folder. Now, removing a folder presupposes that it's empty. So you're going to need to delete any contents in that folder before you delete the folder itself. To remove a folder is a call to os.rmdir and then the path to the folder. Of course, I'm not giving a fully qualified path here because I know my current working directory is appropriate. Otherwise, I would have to, between my single or double quotes, qualify the path directly from the root all the way up. Good deal. To delete a file, you're probably wondering about that, we can just call os.remove and then provide a full path, partially qualified path, or in this case, I'm going to just call the file name, and the file's gone. Onward and upward to opening files in Python. We've looked at several types thus far, haven't we? String, list, dictionary. I'm not going to repeat them all again. You're about ready to meet another file type, and that is, you guessed it, the file type. What we're going to do here is learn how to access and open files for reading and or writing. It's a pretty straightforward process to create an instance of a file data type. Here's what you do. You want to create a name to capture the file. I have MF that stands for my file, creative, huh? And the function to remember here, friends, is open. When you're working with files in Python, you're going to be working with this function all the time. You don't have to import any other modules. It's baked right into Python. And the way open works is simply this. You use your single or double quotes to give just a single file name, partially qualified path, or full path. As you see here, I've completely pathed out my file.txt. And then if you want to, you can close the function there. That will create a file handle, and if you run a type on MF, it'll come back as a file object, and it opens it for reading. Now, that's the R processing mode, what you see here. If you need to edit a file, or alternatively, if you want to create a file from scratch, you'll want to do the path to the file name, comma, and then you would do W for write. Write is used to both add content to an existing file or to create a new file. I would recommend you use this to create a new file and then add new content to it. The reason I say that is, and this is a common newcomer mistake in Python, let's say you create a new file using the W processing mode, you add several lines of data, you close the file, you reopen it with the W thinking you wanted to add new data at the bottom of the file. Well, you're going to be unpleasantly surprised to see that Python gets rid of everything that was in the file previously, and you then start from scratch. That's what the A is for. The A processing mode stands for append. So you'll create the file for writing with W, add your initial data lines, close up the file, and then if you want to add additional information to the file, make sure you use A. Once again, if you don't supply a processing mode, it's assumed that you're opening the file for read. Finally, you can do a B. Well, I'm not going to say finally because there's one more processing mode identifier I want you to be aware of. B simply stands for binary. You can open up binary files. We're going to be working with just plain ASCII or Unicode text files here in this nugget. If you're opening up a file and you don't want to see those mappings of just binary data, because really when you think about it, even a .txt file is binary, it's just that you're able to do human readable text recognition because of ASCII and Unicode. B opens up the naked binary. There's better ways to use B, quite frankly. There's better ways, I should say, to viewing binary data like image files, database files, PDF files, than trying to crack it open with B. But the B does have its place, and we'll be using it a little bit today. Finally, you should know, if you don't already, that the new line gives us what's called a line feed, or a new line in the file. Depending upon your OS, whether you're Windows, Mac, or Linux, you might see a different escape character used for new lines. If you create a file or open a file for appending or writing with U is uppercase by the way, that applies the universal new line character \n and make sure that that's standardized. So this is going to be useful if your file is handed back and forth among different computers of different operating systems. All right, cool. So what do you do, or what can you do once you've used the open function to create a file object? Well, you can do reading and writing. It's as simple as that. You'll note that we have two choices for adding new data to a file. You have write or write lines. The main difference here is flexibility. If you're just going to write a line at a time using straight quoted strings, for instance, string literals, then write is fine. Write lines, of course, is intended for more robust data entry. What's especially cool with write lines is that it takes object types besides just string data. With write, you can do, say, a triple quoted string and add new lines and all your advanced formatting that we've come to know and love, and that'll work all day long. But if, for instance, you had a list that you wanted to slam dunk into a file, there it's not going to work passing in a list as an argument to the write function. There you'd need write lines. On the other side of the equation, to read a file, we have, again, quite a bit of choice here. There's read line, read lines, and read. Well, when are you going to use which? Read line is used for, at least in my experience it is, smaller files or files where you're not looking to scan the entire thing. It's exactly what you think it is. If you run, in this case, mf.readline on a newly opened instance of this myfile.txt, you're going to get a string back that's just the top line of that file, and you'll need to rerun the readline command to get subsequent lines. You'll know you've reached what's called the EOF, or the end of file, when you get an empty string back from Python. So readline can be nice to view individual lines in the file. As far as reading the entire file at once, you can invoke the read function. This takes in either just n number of bytes of the file if you just want to do it in chunks. If you run read with no arguments, the entire file gets packed into a single string. Now that can be a little problematic with huge files. You want to keep in mind memory conservation, of course. Read lines is like read in as much as it's going to read the entire file to the EOF, but check this out. Your output, instead of being a single string, is a list of strings. And we know we can do a lot of neat things with lists, don't we? So that's the main distinction. I hope you're clear now on the ways we use the read functions and the way we use the write functions. Officially, if you want to be letter of the law, you should close your file handle when you're finished. This is considered optional by many sources in the Python documentation. However, I think it's a really important step because remember, when you have a file open for writing especially, other people, that is to say human people, not just Python programs or any other program that might access that file, anybody is going to run into problems trying to access that file because it's locked open by the operating system and certainly more specifically by Python. So to close a file, to release the file handle to the operating system, and to allow other processes access to the file, you can simply call the close function with no arguments and you're done. Now what I'm going to show you now, I'm going to show you a lot in our demo, but instead of just doing read line, read, or read lines, best practice, if you really want to be a Pythonista here, is to use the contents of your file as an iterator and to run a for loop with the readline function to zip through the file. Doing that is much more parsimonious and easier in terms of memory consumption than is either read lines or read, because remember, with read you get a single string, read lines you get a list of strings. If we're doing a for loop with readline, we're being much easier and allowing garbage collection to easily take away elements that we no longer need. Enough flapping my gums. Let's do another demo. Alrighty then, let's get right to work. As you see, I'm showing you the output of both the getCwd function and the lister function to see what we're working with. I'm going to create a brand new text file now. I'm going to create a name called f. Of course, we have the open function, and I'm going to supply a new name here. We'll just call this testing.txt. Now remember, if I just hit enter here, we're going to probably get an error. Yeah, we sure will. Simply because there's no such file or directory. So what we need to do is make sure to add a comma and W to create that file. I can show you that by switching back to Windows Explorer. You see testing.txt. If you want to trust me, that file was not there a moment ago. Now that we have the file open for writing, we can use the write and or write lines function to add content. Now first I'm going to use the write function. And I'll pass in a straight string literal, and note that if I do want to do a line feed, I'm invoking that as part of my string with the \n escape character. You get back from the write function the number of characters that you've added to the file, and if you were to count up these spaces and these characters, you'd come up with 24. Now write is going to just do a line at a time, so right now we have just one line in our file, don't we? We can call write again, and I'll add the second line of text, 25 characters. Let's close the file. Remember how important it is to do that. We've closed the file handle, and if we want to open it, I'm going to reuse the f name here. And because I'm going to read this time, note that I'm not adding any other parameter. I could, if I wanted to, do this, but it's just extra characters. No need to do that. If I do an f.readline, we get our first line of text back. If we do a second readline, we get our second line. If we do a third readline, we get our end of file or empty quote. Now this is a neat trick. There's a function called seek where you can place the cursor anywhere in that data stream. If you want to go back up to the top of the file you can just call seek and pass in 0. That takes you all the way up to the beginning of the actual file. So if I do f.read with no parameters, I get the entire contents of that file back as a single string. Let's wrap that in the print function, and we get nothing, which shouldn't surprise you. Remember that after you've scanned through the file, your cursor is at the end of the last bit of text in that file. So we're going to need to reset our cursor with seek, and now let me re-invoke the print function. Print is definitely going to make your file look a lot easier. Here we see that instead of echoing the actual new lines, they're being interpreted by the print function and shown in a much more eye-friendly way. Let's close this guy again, and we'll open it yet again, this time adding data to the file. So we know that that's the append or a keyword, and this time we're going to call the write function again, but I'm going to do triple quoted string with embedded new lines. See how that goes. Came back with 77. That's fine. We'll close and we'll reopen for read. And this time I'm going to do print f.read. And you notice that the append worked just fine. Of course, this little glitch here is part of the string literal. That's just an accident on my part. We'll finish this consideration of opening, closing, reading, and writing files by closing the f file handle yet again. And I'm going to create a small list now of arbitrary names. Okay? Tim, Susan, Zoe, and then we're going to open testing.txt one more time. Well, actually, it'll be one more time after this for write. Now, remember what's going on here. I mentioned that unless you use append, you're playing with a loaded gun in terms of the contents of that file. So keep that in mind as we go on here. So now we have the testing text file open for writing, and I'm going to call not write, but write lines. Remember, write lines allows us the flexibility of passing in other object types. First, just for grins, let's try to pass namelist into the write function. We get a traceback, and it's a simple type error telling us that list is not allowed. We can only put in a string, which is all well and good because what we're going to do now is change the write function to write lines and pass in that namelist list. That took it just fine. So if we open the file for reading, we see that the only contents of that file now are the contents of the previous namelist string as a single string. So if I type out the read function in the f file handle, the class there is string. Now we can split these names up in several different ways. We've looked at string methods earlier in this training, but for now I'll just leave it at that. But wait, there's more. It seems like every time we finish learning something, there's just so much more around the bend that needs to be gone over. I want to show you how to conserve memory by bringing back lines and files as iterators rather than just packing the whole file contents into a single string object. I told you that can be done, and it can. What you're seeing here is a simple text file called lines2 that contains, 8 or 9 different items. They're obviously programming language names. And if we come back to the interpreter, I'm going to create a simple for loop here where I say for line in, and then the iterator here is a call to the open function, lines2.text.readlines. Remember, readlines gives us a list of strings as its result. In the for loop, we're simply going to print the value of line, and we're going to end with the EOF, or the empty quotes. See? Really nice memory efficient way to buzz through the contents of a text file. Time for some more file and folder tricks with Python. These are some really, really useful functions and a useful module that you'll want to be aware of. The question arises, what's the easiest or most efficient way to traverse directory structures? Well, os.walk, a built-in function, is a great way to do that. Walk does what the name means. It allows us to walk through the contents of one or more directories recursively to get back whatever contents we want. If we just want to do a list dir, for instance, we can gather the contents of those directories. We don't have to get all contents. We can do searches, pattern matching searches. Speaking of pattern matching searches, we have the glob module, which if we import glob along with OS gives us tremendous flexibility in not only being able to walk through a complex directory tree, but also the glob function in the glob module is used for wildcard processing. So in other words, we can use, say, the asterisk character used as a wildcard character in most, if not all, current operating systems to gather all files of, say, a particular extension, all files that start or end with a particular substring. You might have heard the term regular expressions, or regexes as they're called. Regexes are a bit beyond our scope in this training. Glob provides a really nice candy-coated front end to that kind of thing, where we're wanting to traverse a fairly complex hierarchy of folders and files, and we only want to return files and resources that meet certain criteria. Third, you need to understand how to pickle objects in Python. Now, if you hear Pythonistas around the water cooler talking about, well, I'm going to pickle that and send it to you as an email attachment, you're now about to know what that means. Pickle is a built-in module in Python distribution that provides portable storage of structured data. Now, what the heck does that mean? Basically, with Pickle, it makes complex data structures portable to where you can, in a sense, kind of zip up. I'm sure you might have used WinZip or WinRAR on Windows systems, Stuffit on Mac systems, tar, etc., gzip, ways to compress files and for easy transport from system to system, platform to platform. Well, that's what Pickle does, but what's especially cool about Pickle is that the input, the data types that it takes, are pretty much anything supported by Python. So you can take lists, you can take dictionaries, you can take XML, Extensible Markup Language, or JSON, which is a pretty popular data representation format used in the Java world, and pack that into a file, and that file gets stored with your complex data. If we can zoom in here and take a look at my sample code, we're starting with a list data structure that we've attached to the name A. We import Pickle, we create a file that's going to serve as our Pickle repository, as it were. Notice that we're writing this or creating the file for editing in binary mode. Pickle has a simple function called dump, where you can take your input and pack it into your output file. In this case, A is going into F. You then close your Pickle file, bring it to your destination station where you want to have access to this data structure, create a new name, call the open function for read, and as long as you have Pickle imported on the target system, you can invoke the load function, and then you have that name directly available in your code. Isn't that awesome? So that means this A, these are two separate machines. They could be on the different sides of the globe for that matter. We can do an A here and echo back the contents of this list. We can do a type A and it would come back as a list class, the whole deal. So I hope you see how useful Pickle is for taking structured data, packing it down into what's called a persistent state. It's also called in the Python literature a way to serialize or just create a series of binary digits of your data type for portable movement across the internet or the network, and so on. Now, if there's a downside to Pickle, it's that there's no security checking in there. You want to be really, really careful, just like you want to practice safe web browsing and be careful what files you download and open on your computer. You want to make sure to only open up and use Pickle objects from trusted sources, because really anything that's been pickled, once you unpickle it, it could delete objects, it could delete existing data structures, it could do some pretty potentially catastrophic stuff. So be aware of that. Let's now walk a directory tree using os.walk and do pattern match searches with glob.glob. You're seeing our files sample folder where we have a plethora of different file types. We have a subdirectory called sub that contains a handful of files all containing the same extension. So let's fire up the Python shell now, and first let's verify where we are. We're still in the files folder. That's what we want to do. Very good. Now how we're going to do this, how we're going to invoke oswalk is in an iteration. We're going to use a for loop here where we're saying for root, dirs, and files. The root in Windows is going to be C. Dirs is going to be our directory path starting at files. And then files are objects within that folder. The iterator is a call to oswalk in the current directory. Pretty easy, right? We could do a hard-coded path here, or I'm being more efficient or more Pythonistic to make a call to oscurdir, Let's hit enter, and in the second line of the simple for loop, we're going to use some string formatting, call to the print function, and in that call to the print function, we're using, for the sake of practice, the Python 3 style string formatting, which, if you've had experience with both the old school C style string formatting and the Python 3 style, I like this better. I think it works pretty easily. So what we're echoing back first is the string literal 0 has 1 files. We're calling the format string method, of course, and passing into it the root object, comma, and then the length of files. So what this should tell you is we're going to get back the number of each object in that folder. So in this case, dot, which you Unix, Linux, and Mac OS people, and even frankly those of you who go back into the MS-DOS days should know, is the current directory, has 7 files. And if we go into more files, there's nothing in there. And then, as I showed you, the subdirectory has 8 text files. Simple example of how to walk a directory tree. Next, without any hesitation, let's import glob. That's a built-in module. And then what we'll do is call the glob function from the glob module. This is going to, we put in a path name and it returns a list of paths matching a path name pattern. So I'm going to pass in a full path here, files, and then we'll go into sub, and we're just going to grab all of our text files. Now we already know the answer to this, don't we? Yes, but it's nice to see it come back. Now notice that glob gives us a list of strings. We know that we can take this string and do anything we want to it to pretty it up if need be. Another thing we could do again is use iteration. I'm going to say for name in glob.glob, passing in, I'll just add the star after the files level here. And our syntax error here tells us that we left out a quotation mark. Easy to do, right? And in line 2, I'm just going to print the value of name. No big deal. So here it gives us back nice paths, really, of all the contents of that folder. You'll notice that we get directory names and discrete file names. Our last subject in this nugget is how do we open other file types? The ASCII or Unicode text files is all well and good. That's wonderful, very useful, especially in server administration, because you and I both know, I'm sure, that any log file worth its salt is in some kind of plain text format. It could be in a separated value format like CSV or TSV, etc., comma separated value, tab separated value. And what we've learned thus far with the open function will work all day long for those file types. Of course, the question arises, how do we open binary files that will not work or will not work well with the open function? How do we look at pictures, for instance? How can we access Microsoft Office files, which, if you've had experience in the field, often contain a lot more than just text, for sure? The Adobe Portable Document Format, the Microsoft XML paper specification, the list goes on. But we're constraining our discussion in this nugget to images, Office docs, and PDFs. With images, your go-to is going to be the Python imaging library, PIL, which is a collection of modules. The one that you want in particular is the image module. Here's the downside with Python imaging library. As of this recording, it's available only for Python 2. Now, you may be able to get a beta version, or I'm not going to say hacked, I'll say adapted version of the PIL for Python 3, but this harkens back to the fact that Python 3 is still relatively new, and it's a big jump, actually, to step on my soapbox for just a minute, between Python 2 and Python 3, because remember, as I stated earlier, any new features added to Python from here on in are going to be added to 3 and not 2. That's one. And also, 3 is the first Python version that's not compatible, backward compatible, with earlier versions. So as we've known, a good case in point would be the print function. Print is a statement in Python 2. So if we try to run a Python 3 program in 2 and vice versa, it's not going to work, you see. But the bottom line is, again, as of this recording in May 2010, Python 2 is still the predominant version of Python. All right, so enough about that. Python image library, the image module to get to images. There's other ways to go, of course. I'm just giving you what I think are the most popular, easy to get to modules. For handling Microsoft Office, again, there's a few different ways to go. Probably the most popular way are the Python extension for Windows. This is called PyWin32, and I have verified that this does work in Python 3, which is cool. There are also Office application-specific extensions and packages. Python Office, for instance, gives you rich ability in Python to read and write Excel workbooks and worksheets. Finally, for Adobe PDFs, there's Report Lab and Swift Tools. Swift Tools is a collection of components. What we'd be interested in to look at PDFs is their GFX module. In this final demo, we're working with a previous version of Python. As you see, we're in idle, we're in the Python shell, but we're working in Python 2.64. I've also behind the scenes gone out and downloaded and installed Python imaging library and made sure that those components are in the appropriate location. We're going to be covering module programming very shortly, but one more time, let me open the File menu and select Path Browser to remind you that if you install any third-party modules and extensions, dollars to donuts, they tend to go under the Python directory, under lib, under site packages. And you notice that the Python image library has its own folder and it exists directly in the syspath variable. All right. So what we need to do to access images here is, first of all, it'd be easier if we would get to the appropriate directory. Let me import OS and do a getcwd, that is to say os.getcwd. Get it right, Timmy, get it right. And we're going to need to change our directory, aren't we, to the location that contains our image file, which, as you know by now, is in the Files folder. Now that we've done this, let's import image, which is part of the Python imaging library. If we run a dir on image, you'll see a lot of names. The function we need is right here. It's appropriately named open. And again, to hint to what we're going to be learning in the modular programming nugget, it's nice that we have what's called a namespace active, because we use open to get to files, don't we, under normal circumstances? How does Python keep things straight if we make a call to the open function? Well, the way that it's going to keep it straight is I'm going to create a name and path out the open function from the image module. And I'm going to give the full path here, just to be safe, to my file. Now, this is neat. This is a neat feature of idle. You'll notice that you get the context-sensitive help here as you're typing, not only for built-in methods and attributes of objects, but you'll notice that when you're working with file paths, you get a pop-up that gives you help there as well. So I can select tim.jpg just from the list and go on from there. Now, all I've done right now is create a file handle again. So if I run type against im, I've created what's called an instance of that image. I'm going to need to invoke another built-in function of the image module now. You'll see there's a lot of them. I want show. And there I am. That's yours truly. And then to shrink the window up just so you see what's going on here. What happens is that the call goes out to your operating system, and whatever is your default handler for files of that type, in this case it's JPEG, and on my system it's Microsoft Office Picture Manager. It might be something different on your system. That's the application that intercepts that image. We're going to go right on with the show now, and we'll look at examining PDF files. Now, different modules and different packages have different levels of functionality. The GFX module that comes as part of the SWF tools is okay. It's not everything I would expect in a PDF viewer, but it's all right. So what I'll do here, since I've already, again, behind the scenes, gone ahead and installed Swift Tools, I'll install or import GFX into our environment. And now I'll create a file handle called doc, and here again we have the open function. This time it's an open function within the GFX module. And the tooltip help says that our two arguments are type, comma, file name. So our type is PDF, and then our file name, I'm going to try just a relative path here. I have a PDF called itil.pdf. If I want to get document properties from that PDF object, first let me just for grins run a type, and it looks like we've instantiated a class of doc from GFX. Now don't mind my use of the word class here. We're going to be working with object-oriented programming again later in the course. I'm assuming that you're watching these nuggets serially, one after the other. And now that I've created the PDF file handle, I can hit the dot to bring up the method list. Unfortunately, GFX doesn't give you an awful lot of ability. You can get metadata properties. That's what getinfo does. You can set properties or set parameters to the file, but it's still pretty basic. I think you have the idea though. To any problem in Python, you can find the right tool for the job, that's for sure. File handling review. Well, clap yourself on the back, friends, if you're comfortable with what we've covered in this nugget, because this was a pretty heavy-duty nugget, no question about it. We learned how to interact with the host enclosing file system that exists outside and surrounding your Python environment. You now should know how to traverse the file system to create folders, to change your current working directory, to create files. Actually, that's the second piece here. How to create files, read files, write to files, append to files. Not only your traditional ASCII or Unicode text files, but I also threw in some extra stuff on accessing image files, MS Office files, and Adobe Acrobat PDF files. I hope that this has been informative for you, and I'd like to thank you for viewing.